thing, huh? Right?
Hello.
Yeah. Hi. I'll start class in another 8 minutes, okay?
Um, waiting for that.
Hello, can you hear me? All of you?
Yes, ma'am.
Okay, good. So in the last class, we gave you a brief overview of what this course is going to be. Or just before I need to ensure that I am recording. Okay, yeah. So we talked about the importance of this course in the we talked about the overview of this course, and as I said, the primary objective of this course is to design elegant, efficient, and readable programs. Okay, and then yesterday, finally, towards the end of the class yesterday, I talked about the relevance of this course in the CSE curriculum, where it fits in place. And in my opinion, I personally believe that programming in data structures is like your heartbeat, okay? You have to, whatever be the area that you work in, does not matter whether you work in theory or hardware or applications like machine learning, computer networks, databases. This is going to be a very important course for you, okay? And we took, so basically, we talked about various ways of doing it. And let's look at this example on navigation. Today, smartphones have become ubiquitous and you can do everything. Perhaps many of you are connecting via smartphone to this particular class. Let's say my objective is to find the nearest restaurant serving Italian food or Italian type of food. So, what are the restaurants that you know, which I know Italian food is very popular. Yeah. In fact, it's very popular in India. And can some of you name some of the Italian restaurants other than the ones that I put in the list here? Can you see my slides?
Yes.
Okay. Can you tell me, I've given here Little Italy, Crimson Chakra, Pumpkin Tales is borderline. And can you tell me what are the other restaurants that are available in the neighborhood which serve Italian food? You're all in the second year now, right? You must have traveled or you've never been outside the campus. Does anybody know? Okay, I'll assume that you do not know and I'd like you to find out. Let me give you one excellent Italian restaurant which I know, Pantry Door there in either Raja Damalipuram or Mylapore. It's an excellent place too. And I want to look at the number of restaurants in the vicinity of IITM, and you will find you need to do some counting, and there will be a large number. And this counting problem belongs to the area of discrete maths. Now you want to find out which is the closest, and then you will use programming and data structures. At the same time, the best food is a little vague. So what we will do is we could represent this entire problem of a set of restaurants and the distance from IITM. Let's talk about closest alone. We'll not worry so much about the pocket. We'll talk about that a little later. Maybe you can compare, how much does a lasagna cost in Crimson Chakra versus Little Italy versus maybe Pumpkin Tales, Pantry Door, and so on. Of course, the drawback of something like Little Italy is that it's a vegetarian restaurant. So that might, many of you might just dismiss it. So there are other places. And so you're looking at time and pocket costs. Then your programming and data structures course will help you find this. And we'll see how we will do it very efficiently using specific type of data structures and algorithms that work on those data structures. And the question is, how do I code this information into a computer so that tomorrow I'm in a different city and I'm giving it a different set of restaurants, or maybe I connect it to Google Maps and ask it to find out. Then coding this information belongs in the area of languages, machines, and computation. Why do I say that? We require a programming language, and in that programming language, we have to code the information, primarily being Why do we need this? Why can't we just code in English? Can somebody answer that question? Why is it today you can do a little bit of machine learning, but many times it'll get your answer close to what you're expecting, but not the correct answer. The primary reason for this is, let me give you this sentence, okay? And I want you to disambiguate what I am saying. The teacher said the student is a fool. What is the meaning of the statement? Can anybody answer? Can Arun answer? A.R. Arun. What is the meaning of the statement, the teacher said the student is a fool? Sai Shashank Reddy, can you answer what this means? Hello? Can you people unmute your phone? Unmute your mic, or you cannot?
Hello?
Yeah,
Okay, yeah. Sai Shashank Reddy, can you tell me what is the meaning of the statement? The teacher said the student is a fool.
Maybe the name of the student is undetermined.
Not that. Let us say this, it's referring to a particular student. The teacher said the student is a fool. Let me give you slightly differently, okay? Suppose I said, the teacher said the student is a fool. Whom are we referring to? Are we referring to the teacher or to the student? The teacher said the student is a fool. Okay, let me use my iPad, and let me do a new share. Can you see my iPad?
Yes, ma'am.
Okay, now I'm going to give you this, okay? Suppose I write this like this. The teacher said the student is a fool. And the teacher said the student is a fool. Okay? And I write this in English without the punctuation marks. The teacher said, and I'm saying it very fast, the student is a fool. So I gave you the last sentence. Okay?
Yeah.
Is this last sentence unambiguous?
Yes, ma'am.
Is it unambiguous?
Yes, ma'am. It is unambiguous.
It is ambiguous, right?
Yes.
So this is precisely, those men in their flying machines. We have large number of examples of this kind, which kind of make it difficult to use a natural language to decode a program. So that is why we need a programming language. We'll talk a little more detail about this. And this is where languages, machines, and computation come in, where you will learn about finite state machines, and you also have a course on compilers and how to write programming language. In fact, in compilers course, you will actually learn how to design a programming language such that the statements mean unambiguously a particular kind of computation. Okay. Okay, that's why natural language is still an issue, and that is where machine learning comes in. Okay, and you want to run the program efficiently. Okay, and that is where you need computer organization and architecture. There's something called the von Neumann architecture. There's a Harvard architecture, and now with the arrival of the GPUs, you also transfer a large percentage of your computation. So what we do is we use some clever data structures, and when we use these clever data structures, we can transfer the computation to a GPU to do the computation for us very efficiently. Now, of course, this question here, best food price, this is not clear because this is quite subjective, and you need a recommended system for every person. For example, a person may be a vegetarian, person may not like garlic, or person does not like a particular type of food, and so on, doesn't want cheese in his food. You want an Italian restaurant without cheese in its food is like an oxymoron, but nevertheless, you may want something like that. These might be your preferences. So best food and price, you need algorithms like machine learning. Okay, and it is the problem with machine learning is that data intensive. Therefore, you need good GPUs, and among the various GPUs, there are different types of GPUs which you would like to ensure. These are graphics processing units, which essentially do some kind of matrix manipulation, and these are fantastic for doing large computations. And you want to reserve a space via the phone. Okay, so what you're doing is you're using your navigator, whatever it may be, and you want to reserve a particular place. All this requires computer networks. Okay, whether you're using voice, most people today, there is no distinction between a voice call and uh, a video call or a network-based call. Earlier, there used to be a lot of distinction between them. One would use what is called circuit switching, and the other thing would use data switching and packet switching, as we call it. But today, everything is merging, and you have computer networks which kind of solves the problem for you to make a phone call, and while you're looking at it on your smartphone, and say that I want to use this I would like to use my I'd like to reserve a place at this particular hotel. Then what happens is you went and you had a great dinner, or you had a horrible dinner, and you want to remember the attributes for the future. Okay, navigation included. So, did you have to go through small streets? Unfortunately, I do not know how many of you have had this experience. I've had this experience with Google Maps, that many times it will show me some silly streets which actually do not exist. They're mud roads, and you can't take your powered two-wheeler. You can at most walk. So maybe you would like to keep some attributes for the future. You would also like to keep the attributes of the restaurant, and this is what will be stored in a database. So all these courses have their relevance in the computer science curriculum. Today, machine learning seems to be ubiquitous and getting into every thing. For example, for example, use a lot of, in fact, I use speech interfaces quite a bit. I like to use speech interfaces because I work in speech technologies now. And I say, hey, find me the best restaurant. Sure. And it uses underlying all the other areas and uses some special type of algorithms to find out the closest and best restaurant for that suit my taste, because also machine learning also keeps track of each individual person's choices and tastes. This can be done even in the context of recommender systems for, kind of music that you like. You just want to take rest, and you'd like to put some music on, and you don't want to, go and search and find out which video you'd like to listen to or which audio you'd like to listen to. On the other hand, it would be so nice, hey Google, play my favorites. And it should go and start playing your favorites. And that again means it has a database of songs. It has your preferences, which have been stored as attributes, and it very efficient. You can't wait all day, and you don't like the idea of, Google comes back and says, I don't understand what you're saying, which is what many times it does. It'll like say, hey, here's what I have for you, and something like that. Efficient programming, data structures, counting, everything comes into the picture, and it does use a programming language in which everything is coded, and it gives you the results in an unambiguous form. More examples, for example, when you're taking Uber, for example, or the Ola, you'd like to find out availability of cabs nearby, store addresses that are suggestive, categorization of available cabs. Are there other sharers who are nearby? How long will it take? And render the changes as I think all of you do this when you're signed up for an Uber or an Ola. And normally I have had this problem when I have to go to the airport, and it'll give me a taxi somewhere which is close to the airport, and that fellow will be static on the map, not moving. Then I know that I'm going to miss my flight. And you'd like to keep tracking continuously, keep track of previous travels. Okay, this particular service, Uber or Ola, at this particular time was not good for me, and so I'll choose the appropriate taxi or appropriate taxi service that is there. So a lot of such examples. So in this course, what we're going to do is organize the data so that they can be retrieved efficiently. So we need what are called data structures, and both data structures and programs work hand in hand, and you operate on the data, and are important for overall efficiency and ease of use. So this is something that we will learn as we go along in the course. The data structures and the algorithms that operate on the data structure are tied together very efficiently. And this is something that we'll keep doing. And that is the reason why we like to talk about abstract data types. And maybe initially you don't have an efficient program and a great data structure, but as you go along, you'll start implementing better and better data structures, and everything should be kind of hidden from the application that is using the data structure and the algorithm. That is what we will see. There are some general misconceptions about what a data structure is. Data structures get created when you use struct. This is a misnomer. In fact, there are languages which do not support struct at all. Struct is a C construct, not there, but you can still make records. You can make a record of a student having a heterogeneous set of items, like your roll number, the courses that you're registered, the marks that you got, which hostel do you belong, and which year you are in, which program are you registered for. All this can be done even without a structure. Okay. And there's also this other misnomer that data structures need pointers. Again, we will use pointers as and when required. Again, this is not mandatory. Okay. All right. And every algorithm uses a specific data structure. No, we will see this. For example, when we implement a stack as a linked list and an array, you can almost use the same algorithm to operate on a stack and an array. We will see how this can be done. So it's not necessary. And this is another misnomer that C++ has more data structures than C. These are two languages which we will be dealing with in this course, which is completely again a misnomer. Yes, many C programmers have become C++ programmers in the world. And the primary reasoning for this was having programmed in C for almost now, I think 35 to 40 years. I can tell you that, initially C used to be terrible. Now it's become a lot better. Let's give you a segmentation fault, and you have no clue why it gave you the segmentation fault. We did not have debuggers that were there, or it will not tell you, hey, there's a type mismatch and so on. It just give you a seg fault, okay? And there will be some inane error, which looks like a operating system error that is there. C++ does much better in terms of giving you error reporting. So many times you'll find that most people still program C-like, but actually do C++. There's something else that I also need to talk about. It's not that for designing and implementing abstract data types, we need C++ or C. You can program in any language, okay? You can program even in machine code or in assembly language. It's a discipline that you observe when you code, that there is a data and that data is organized in a particular way and only operated by a set of programs that can access that data. Okay, this is something that's very important. And there's also this belief that there are total 7 data structures. No? This is again misnomer. And union find, if some of you have heard, is the best data structure. These are all misconceptions. And what is a data structure? A data structure is about organizing data such that its storage and its retrieval improve the efficiency of the algorithms using it. This is a very important point. A data structure may be used by multiple algorithms, and an algorithm can also use multiple data structures simultaneously. Okay? And you can have an array and a list to represent a graph, for example. An algorithm and an algorithm may also use different data structures and achieve the same computation. What I mean by this is the underlying representation of the data can be as like an array or a linked list, which are the fundamental tools that we have in a programming language for putting data of a similar kind, of a homogeneous kind. And it's possible that I may achieve the same complexity whether I use an array or a linked list to represent a particular abstract data type. And we will see that it's a question of how efficiently you write your algorithm. The data structure alone by itself is inadequate for doing this job. Okay. So the various data structures that we will see in this course, I've given you a picture here. An array consists of a set of homogeneous elements which are of fixed length. When I say elements here, the elements can be lists, it can be structures, whatever. Similarly, when I talk about a linked list over here, the array is a very nice data structure. It's extremely useful. And what is good about it is that an array enables what is called random access. I have, let me go back to my iPad. So what we are talking about is something like this. When I'm talking about an array over here, unfortunately, I don't like C starting with whatever it is, we live with it. We have, let's say, an array here, A of 0, 0, 1, 2, 3, 4, 5, 6, and 7. Okay. So what I mean over here is that I can what I mean by this is that you can index the, you can choose any element. Let's say, I have red D1, whatever, and Katarwa here, and so on. And let us say Srujan here, and I have Alan here, and Anirudh here, and so on, various people. I can look for, I can go directly to A3 and get all the details about Anirudh. And I can go to A6 and get all the information about Srujan. And I can go to A1 and get all the information about Atama. This is what we mean by random access. Okay. So what we mean by this is that I can directly access using the index of the array, I can directly access the particular location and get all the information. Whereas if when I'm using a linked list, I'm going to say Reddy and Atharva and so on, Anirudh and Alan and so on, dot, dot, dot. And let's say this is the first element, 1, 2, 3, and this is the eighth element. And then I come to the end of the list. So what is the advantage of this and what is the disadvantage of this? What is the advantage? What is the difference between? So, the array, the good part is it is enables random access. But is there a drawback of the array? Can somebody answer this? Banot Vivek Raj. Is there a drawback? Can you answer? Is Banot there? Vivek? Okay. Looks like he's just turned it on and gone. We're not taking attendance, man. You don't have to worry about it. Shanti? Bulli Mera Shanti. Can you answer? What is the advantage of an array and what is the disadvantage of a linked list? Or what is the advantage of a linked list over an array? I want this to be interactive. Can you answer? Chetan Reddy? Deepika? Nobody's around? Can you unmute your mic, Deepika, and answer? Sai Teja? Is anybody around or just have set on your Zoom call and gone away?
Yes, ma'am.
Okay, who is this?
Tarun.
Who is this?
CS6. Tarundeep, ma'am.
Okay, can one of you speak? What
Yes,
is
ma'am.
the difference between an array and a linked list?
Once the size of the array is fixed, it cannot be changed.
Okay, and
For linked list, we can change the length.
change the length. But is there anything else?
We need the head
One thing
pointer
at home, is it?
value to access through linked list.
What is that? Sorry, repeat.
We need the head pointer
Yes.
for accessing through linked list.
So in a linked list, you only have to go through the head pointer and not in the head pointer. I have to go through each one of these elements. I know if one of these nodes, let's say the information gets corrupted, then you've lost complete access to the rest of the list. Whereas in an array, even if some, let's say Anirudh's records have been misplaced or whatever, you still have access to the other records in a array. So there are advantages and disadvantages of the two basic data structures that we will be looking at. And then there are, but the point is, if you look at it here, so you have an array, we have a linked list. Now, here is a tree. This is what we call a binary tree because I've given two branches from every node. Notice that here it has, the root node has two branches and it can have one node, it can have one branch or no branches at all. This need not necessarily be the tree representation. I can also have something like this. Okay, I can have a tree which is an M array tree. Okay, 1, 2, 3, dot, 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 to M. It can be an M array tree which can have M children, 0, which can have from 0 through M children. And this is also very quite a popular data structure. We will do quite a bit on binary trees, but the important point is that, and the important point is that, can you see my slides now?
Yes, ma'am.
Okay. The important point is that the this binary tree that you're looking at here does not mean
Ma'am,
that
we are not able to see the slides.
you
No.
cannot see my slides.
We are looking at your notes.
Okay. All right. So, but a binary tree, for example, need not necessarily be represented using only a linked list. It can also be represented using an array. Okay, we will see this in this particular course, how this representation is going to happen. In fact, not only a binary tree, I can represent an m-array tree by an array, and we will see how we do this. And in fact, that kind of an implementation of the data structure can actually be very useful in certain kind of algorithms. Okay, so algorithm and the data structure go extremely hand in hand. And these are the standard data structures. You have array, you have a linked list, which are the two basic fundamental underlying tools that are available in a programming language like C or C++. And on top of it, you can represent a tree, you can represent a graph. These are data structures that we look at. This is a binary tree. You can represent an m-array tree over here, as I showed in my iPad. And you can also represent a graph. This is a directed graph. Why directed? Because I have edges which go from one node to another with arrows which are pointing, which says there's no arrow pointing back. You can have directed graphs, you can have undirected graphs. The navigational problem that I was talking about is very nice to represent in terms of a directed graph because you have one-way streets. Okay. And a tree, for example, is also extremely useful, not only, for the algorithms that we do in this course, but I want to broadcast as I'm teaching right now. This is actually a structure called a core-based tree. And what I do is I broadcast my information to a central node from where it distributes the data to each one of you. Okay, this is again use of data structures very cleverly and very efficiently. What we want is, we would like that when I'm doing a broadcast, let's say I'm doing like the root node, but I'm not doing it. Zoom is taking care of it for me, sends it to some root node. And from there, when it distributes it to various nodes, it would like to ensure that the distance from all the nodes is the same, so that as far as possible, some kind of a central server from where it can distribute the data to all of you. Okay, so these are the various things. These are the data structures that we will see in this course, and we will look at, if possible, if we have time. So primarily, there are arrays, there are linked lists, and there are then data structures means these are structuring elements that we have. We will see how to build on top of the basic fundamental data structures that are available in a programming language, array and linked list, to build trees, to build graphs, and then we will write algorithms which will operate on these for specific purposes. Okay, so this kind of completes the overview of the course, and let me go on to the next lecture. One of the fundamental things that people do in programming is that, we have, can you see my slides now still?
Yes, ma'am.
It says lecture 2, algorithm design. And here what we're going to do is, we're going to look at something like, how do I design an algorithm that does a particular task. See, so far in CS2700, you've written very simple programs and simple algorithms. I'm going to take one of the simple programs which you have taken, which you have done in CS2700, and use a particular design technique called top-down design. There are techniques called bottom-up and top-down too. And the point is, the objective is to ultimately ensure that the algorithm which is written in pseudocode is translated to a programming language or a program and ensure that it works correctly. Now let's say, how do you decide whether a given program is correct? You design an algorithm. Basically, you write it in sort of English-like sentences. But what we mean is, we'll see what an algorithm is actually, and then translate it to a particular programming language in a kind of mechanical way. This is something that I would also like to ensure that you think. One should think in a language independent fashion. Okay? Compile and run it on the computer. And then you want to test whether your program is correct. What do? You simply run an exhaustive set of tests. Okay? This is fine, but it's not going to guarantee for you that this program is indeed correct. So this is what we will learn. How do you formally show that a program is actually formally does what exactly you are expecting it to do? This is one of the objectives, initial objectives of the course. Okay. So we talked about the terms, algorithms, and programs. And I want to define what an algorithm is. An algorithm is a recipe that spells out explicitly and unambiguously the steps that must be carried on the program, on the problem data to obtain a correct solution, if there one exists. And this has to be done within a finite time. What do we mean by this? An algorithm, if translated exactly into a programming language, into a program in a programming language, must terminate. This quote is from a book called The Design of Well-Structured and Correct Programs. I will share part of the book that is relevant for this course on Moodle. Okay, not Moodle. What we'll do is we'll give you a Google link, and from there you can download within, as long as you have an SMail ID. Okay. This is by Alagik and Arbig. It's a beautiful book on the design of well-structured and correct programs. A program, on the other hand, is a notation that is chosen to specify algorithms to a suitable detail for mechanical interpretation by a computer. So which is the more important part, the algorithm or the recipe that you have. A program is a notation that is chosen to specify algorithms to suitable detail so that enables mechanical interpretation by a computer. Let me give you an example. Suppose you're doing some baking at home. And one person has an electric oven, another one has a gas oven, a third person has no oven at all. You want it, but you still want to bake. But there are other things which can. So these are like three different programming languages having three different ways of achieving the same task. Then what would you do? If you have an electric oven, it's possible that when you're defining the algorithm specifies a recipe, and you need to figure out in the programming language how I would use this particular recipe. Okay, I have a baking recipe. Now, lockdown period, I'm sure all of you might be trying your hands at cooking and various things, given that you have to help out a lot at home. And when you're doing this, for example, what you would do is, how do I, choose the temperature of the oven? And you would have studied a little bit and found out electric oven means this is what I have to do. Preheating perhaps is not required. If it's a gas oven, it requires preheating and so on to get it to the specific temperature that is being suggested. On the other hand, if I do not have either a gas oven or an electric oven, what am I going to do? I might use a cooker. I have every house, most houses today have a pressure cooker. Or maybe I don't even have a pressure cooker. Then what do? Then there are something like, you make what is called, you might have done this experiment in your school in the chemistry lab, something called a sand bath. Okay, what is a sand bath? You take a vessel, put some sand on it, heat it, and the sand will retain the temperature. Then within that you put your vessel in which you will put your cake dough or whatever it may be. But of course the drawback is you don't know the exact temperature that you have to keep your gas on. So you put this on top of a gas stove, heat the sand bath, and then you have to know a little bit more about should I use the big burner, the small burner, and so on. You do all of that. And what we actually do is finally, after you, then you, whether you put it in your electric oven, set it for so many minutes. In the gas oven, you will set it for maybe a few more minutes. And in your gas stove oven, you will again put it in a particular temperature and then set it for a particular period of time so that your cake gets baked correctly. So it's interesting that these are like 3 different programming languages. My algorithm is written in pseudocode. Programs can be written in C, C++, Python, Perl, Pascal, Fortran. Maybe you've not heard any of these. Lisp, Prolog, which are functional programming languages. Modular is actually equivalent of C++, like C was equivalent of Pascal. I just have to give you a small anecdote. C and Pascal, the 2 languages which perhaps originated more or less at the same time. C became more popular because AT&T aggressively marketed it. Pascal came from Europe, from ETH, and did not have a person to market, but otherwise it was actually a very nice programming language. Modular is actually the C equivalent of C++. And today it's interesting that Python actually borrows lots of ideas from modular. Okay, all right. Let's get on. So this is what algorithms and programs are. So I hope by now you understand the difference between an algorithm and a program. Is this clear? Algorithm is written something which is code-like. What do we mean by code-like? If I translate the algorithm mechanically to a particular programming language using the structures and data types that are available in the programming language, then it is guaranteed to work as expected. Is this clear to everybody?
Yes, ma'am.
Okay. Next, what we do is, how do we design a programs that are correct? Next thing is that, I want my program to be absolutely correct, not just by exhaustive testing, as we talked about, but I want to design it and ensure that my program is correct. And today, if you know, many of us write 10,000 lines of code, 20,000 lines of code. How do we ensure that the program is indeed correct is what we would like to look at. Okay, and how do we go about doing this? There is a design strategy which we will talk about. There are 2 types of design strategies, the top-down design and the bottom-up design. As far as this course is concerned, I'm only going to talk about top-down design. And we will see how we do this. We divide a problem into sub-problems. Each sub-problem is solved separately. Then we prove the correctness of each sub-problem. Then we fit the solutions to the sub-problems in the original problem in the order in which they are supposed to be done. And they should guarantee for us a correct program. As far as this program is concerned, we are going to talk about sequential programs and not parallel programs. Okay, parallel programs require a lot of syncing and other things. Here we will assume that every sub-problem has a particular input and a particular output. We solve that sub-problem efficiently and we prove the correctness of the sub-problem. And as long as we ensure that, it's like, these are called impedance matching in electrical engineering, where we ensure that the output of one sub-problem feeds into the input without any ripple effect. What I mean by that, let me um, go back to my iPad. What I mean by that is I'm going to have some input over here. There is a subproblem S1. This will give me, let me call it input 1, output 1, and which perhaps you do some processing or whatever, becomes input to the second part, gives me an output 2, and so on, which perhaps, is the, and let's say we have something like this, and I have n such subproblems, and I have an output n, which is the desired output of the program. Okay. So what we do is in algorithm design, we divide the entire algorithm into these subproblems depending upon the task that we have. We will see with an example. And then what we do is we prove correctness of each one of these. Okay, given this input, can I assert that this is the output that I will receive? And given this output as input to S2, can I assert that this is the output that I will receive? All the intermediate results together. And then once I have proved correctness for this, and so on, and then I tie all these segments together, my program should run correctly. Okay, this is our objective in this particular course. Okay, is this clear? We'll see how to do top-down design, what are the tools that we have in a particular course for doing top-down design. Okay, this is essentially what is the objective of this course. I'll take this example tomorrow. I'll stop here. Are there any questions? Are there any questions from anyone? Today afternoon, we will meet at 2 o'clock. And Mari is there?
Yeah, ma'am, I'm available.
Yeah, so what he will
Hello,
do.
can you hear me?
Yeah, I can hear you. So Mari Ganesh Kumar is like the senior most teaching assistant that we have. And he will tell you which batch you belong to and associate you with that particular teaching assistant. Is this clear? There are 9 or 10 TAs in this particular course, and he will assign you to your batch. And from there on, you will interact with a particular batch. And the first assignment will be done, which is a recap of the CS1100 course. We may not do much of an evaluation except like a pass-fail, whether you completed or not completed, because many of the questions are repeat from your CS1100 course. And that you have to register on HackerRank, right? Anand there?
Yes, ma'am. Can you hear me?
Yeah. So you have to register on HackerRank using your SMail roll number. And Anand will send you the link, right? Or have you already sent the link, Anand?
No, I didn't send to the students.
Post it on Moodle.
Okay, ma'am.
See, hereafter, all information will be available for you. Moodle, we encourage you to look at it. In fact, today morning, when I tried to send the Zoom link to the CSE mail account, it would not work. I don't know whether you received the mail. I sent to UG19 and UG18 and both bounced back. On the other hand, when I posted it to Moodle, I guess most of you saw it on Moodle and have joined the class. Okay, is this clear? So Anand will give you the link and you register on HackerRank and you will solve the first problem on our HackerRank. But as we go along, because HackerRank does not permit certain things that we would like to do in this particular course, we will also use Turnitin and Moodle and TA actually verifying your. So each student will be associated with a particular teaching assistant and who will meet with you every week during the Friday afternoon slot or some other slot if suppose many of you don't have bandwidth restrictions. Is this clear? Are there any questions? Vineet, are there any questions from the class?
Ma'am, one problem can be there, like not all have attended CS1100.
How come?
Oh,
Oh,
CS
the ones
19.
who are, okay. The people who have branch change. Is that correct?
Ma'am, CS19 batch students have attended CS1111.
Yeah. That doesn't matter. 1111 is better than 1100.
Okay, ma'am.
It's more, much more comprehensive. That's not a problem. There are some branch change students, I guess. They would not have attended. They would have attended CS1100 only in January. Is that correct?
Yes, ma'am. Some students are
Everybody
there.
would have done some version of CS1200, which is mandatory. Okay. And the point is, Vineet, I would like you to let me know if any of the students are having problems with accessing. We've already got information as to who has access, who has their own laptops, who don't have their own laptops. We can arrange for compute facility in the department if you can remote login. Okay. If you have a laptop which is not very good, as long as you have something like terminal based SSH installed, you can log in to the institute department computer and do a computation here. Most of the assignments will be terminal based compilation and running the program. So you can do all your editing and everything on your laptop at home and then transfer the file to the institute machine and use terminal based compilation and running of the programs. Is this clear? Okay. So we'll sign off today, and Friday there will be no tutorial class mostly, or we will do some recap and we will upload some tutorial material if required. Okay. I'm not yet decided what I'm going to do because we have barely started the course. Tutorials will surely start from next week. And we will meet today afternoon at 2 o'clock. I will start the meeting, and then after that, you will have individual meetings with the respective TAs. Does this make sense, Mari? Mari, are you listening?
Yeah, that should be fine.
Yeah, can you do that afterwards? I think Mari Ganesh Kumar, you can see him. Anand, can you also turn your video on?
Yes, ma'am.
Yeah. So this is Anand, the senior most TAs in the course. Mari Ganesh Kumar takes care of your theory part of the course. And Anand.
The TAs can also.
Huh?
All the TAs can
All
also.
the other TAs also, can you turn on your video, please? And we'll just close quickly after that. Kartik Raja, then Shivani, Priya Jain, are you there? Okay, we'll do one thing, Mari. In the afternoon, we'll ensure that all the TAs are around and turn on the video. And then I'll just introduce every one of you. And then we will, what we will do is we will do a little bit of brief introduction to C++ in lab course when it's required. Right now you can work with C. As we go along, you will need some background on C++ when I will teach you C++ at that point. Is there anybody, no other TAs around, I think. Is that correct?
I'm here. I'm not sure.
Saish is there. Can you turn on the video, Saish?
Yes, sir. Just a second.
So we'll stop here because I think they have to go to the next class.
Yes, I'm here.
Yeah. Where is Saish? Yeah. Kartik, Saish, and so on. There are 5 TAs here. There are 5 more TAs in the course, and they will join perhaps at a late afternoon show. Okay, I'll stop here. Okay, guys, bye. See you. I'm ending the meeting. Mari, is that all right?
Yeah, thank you.
Okay.